Right, everyone. Everybody feeling pretty good today? I'm curious if when you come to this class on Friday, are you just kind of like, are you just eager anticipation of the weekend and just kind of looking forward? Because once the class is over, then you're just one step closer. Or is it just kind of like a grudging acceptance that you've got one more thing coming up? Maybe a mixture of both of those, you know? I don't know. It really kind of depends on that. The good news is that as we move forward week by week, we're getting closer to summer, and so yeah, that's at the end of this, we have 6 more weeks in the semester, and then finals week. So there's that. So good news, good news. We're starting to see the end of light at the end of the tunnel, the end of the horizon. Whatever anecdote you want to actually use there, analogy, whatever the term is, parable. I don't know. All right, so today we are going to be doing, going back to our old standby, we're going to be doing some Excel stuff, and then we're going to talk about AI. I've got a new AI presentation for you, which we're going to evolve on moving forward. Keep in mind that your AI topic, what's the word I'm looking for? The prompt, basically your idea is due a week from Monday, so on the 31st of March, and it doesn't need to be anything too extravagant. I think my requirements were just a page or two that talks a little bit about the goal of the research and what it is you hope to learn from it, and it's fairly open-ended as far as the topic goes. But I think today will help out a little bit. Some of the stuff you may already be familiar with, depending on your level of familiar with AI. Some of it might be kind of new, interesting. I thought about trying to upgrade to ChatGPT since that was the tool that was being used in the demonstration I was working through, but I'm still going to stick with Microsoft Copilot because I think that's the case. I've actually worked through part of the activity we're going to work today. It worked out pretty well, but we'll see what happens. Before we get there, though, we've got some questions where we're going to be talking about some of the information that we've talked about already. So remember when we talked about the AMPS model, we talked about the 4 different data analysis types. And I said that we were going to be doing some Excel activities on those. So the 2 simple ones are the descriptive and diagnostic, which we're going to do today. Those are just about what happened and why something happened. Those looking at historical data. And then we have the little more complex ones, which are predictive and prescriptive, which look forward and kind of try to predict what's going to happen in the future and make solutions based on that. Those are going to be next week. We're going to do some analysis on those. Now, what we're going to be doing is directly from the book. I believe it starts. I tried to predict the page last time. I think it starts at the end of 263. If you go to 264, it'll actually take you there in the book, but you can actually walk along through it. I'm going to keep trying to go back to these screens and walk through what it is being set up. It's not particularly difficult, but I do think it's very valuable for making a distinction between the different types of data analytics that we're going to be performing in class and making the distinction there. So we're going to start out today, and we're going to do something very basic. We're going to start out with a descriptive analytic, and it's something that if you've taken an accounting class before, I guess I should clarify that everybody's taken an accounting class in this room. But if you've taken 302 with Dr. Eisen specifically, you probably have some familiarity with this. We're going to be talking about an accounts receivable aging. Is everybody fairly familiar with this idea? Now, the irony behind this particular activity is that the author of this book, or one of the authors of the book, Vern Richardson, he is a massive opponent of accounts receivable aging as a method of determining allowance for uncollectible accounts. I listened to a presentation to him I think it was last summer, and he was talking about how the methods that we've got in place now, the technology methods, can actually do a much better job of targeting and tracking information in organizations, so that we could actually do a better job of identifying which accounts are going to be uncollectible and which ones are not. And yet still, all we basically do as accountants is we just divide them into buckets according to age. So we're going to be doing something that's kind of antiquated. I just thought it was ironic given who the author of the book is. This is going to be our descriptive analytic. So this kind of gives you the clue that there's much more extravagant and exotic ways to go about this, but we're going to start out with something pretty basic. So you will need to have downloaded from Brightspace. It's going to be example set data set part 1, example data set 6 part 1. And it should look like this. And we're going to make some modifications to this, but let's just go ahead and talk about what's in the book. So remember, we were introduced to something called the AMPS model, and we're going to use the AMPS model to perform this accounts receivable aging. So the first part of the AMPS model is going to be asking the questions and then saying, pretty basic, how long have the existing accounts receivable been outstanding? All right, that's all the question that we're asking there. We have to specify that question because that's going to be what the detail in the analysis is going to show us. And in our requirements here, it's actually going to show us how we can actually put these into 30-day buckets, 1 to 30, 31 to 60, 61 to 90, so on and so forth. And we're actually going to pull, I'm rambling a lot today. We're going to pull from the 61 to 90 day bucket. So how to do that. So for the mastery of the data, the good news is that you remember when we talked about this earlier in the week, and I said mastery of the data usually takes 50 to 90% of our time. We're going to chop the Gordian knot and avoid that step for this particular class, because that would be all we'd have time to do in the class if we were to do cleanup. We're going to actually have a clean data set for all of our analyses. So we're pretty much going to skip the master of the data set. Basically, your mastery of the data will be downloading the file and opening it, okay? Which it does not the requisite 50 to 90% that we would normally have. But we had to cut some time somewhere, otherwise we'd be stuck on this analysis. All right, so now we're going to do performance analysis. So before we start, let's go ahead and make sure we understand what is contained within the data. It's pretty simple and straightforward. We've got three fields, or three columns, attributes. We have the customer, which is the name of the customer, the invoice amount, and the due date that the invoice was due. And so you can kind of look at this data, and it says that here's the due date of all these items. And then we've got today's date. Now, this is not very well formatted. You'll notice the invoice amount is kind of sporadic. If you want to, you can go in and you can change the format of the cells just to, do it or have it in a consistent format. I'm not going to put a dollar sign, but I'm going to put 2 decimal places, and just to make sure that looks a little bit neater. But what we're going to do is we're going to perform our aging based on what we think today's date is. And for hypothetical purposes, today's date is December 31st, 2021. So we're going back in time a little over 3 years ago to go to the end of 2021. Now, this is going to give us the number of days that a particular item has been outstanding, and we're going to categorize those according to those days. If you remember, we talked about dates and the way that they transform in Excel is that the date is just a numeric value, the number of days since January 1st, 1900. And so we can use those mathematical operations to make calculations. So let's go ahead and just do some basic analysis. First thing we're going to do is we're going to create a column over here, and we're going to call this days past due. And if you type it in, you're going to notice something very unsettling, is that it's in a white font and a white background, okay? So that's probably not going to suffice for us. So let's go ahead and click on C1, and I'd just like you to click on the clipboard paintbrush over here. It's our format painter. We're going to change it to the format that's in C1. So format painter here, click on C1, then click on D1. That will actually change the format over there, which makes things a little bit easier. Just quick way to fix that particular problem. You can go through and manually fix it if you want to, but that's just the easy way to go about it. All right, now we need to calculate our days past due. It's a pretty easy calculation. We're going to start with equals. We're going to go over to G1, and we're going to subtract C2. So we're going to subtract December 31st, 2021, which is today's date, from the due date of our invoice. And that will tell you how many days past due it is, which is pretty simple and straightforward. Now, I'd like to be able to flash fill this down, but I am running into a problem if I try to flash fill it as is. What's that problem?
You didn't lock the today's date.
Right, okay. So if I flash fill it, it will flash fill according to the dates down here, but it will also try to flash fill according to the relative references here. It'll go to G2, G3, which there's no data there. So we need to lock that cell reference. So in your equation bar, your formula bar in days past due, click on G1 and just hit the F4 key. That actually locks in absolute cell references. So that's a shortcut there. If you want to type in dollar signs on it manually, that's fine too. You can actually specify if you've got partial absolute cell references, you can toggle through these by hitting F4 multiple times. You'll notice it goes to just an absolute cell reference in front of the $1 or which one. Which actually would work for our purposes because we want to lock into the row, but not necessarily the column. And then we can lock the column and not the row, or we can unlock, and then we can go back to full lock. Whichever you want from that, you can toggle through by hitting F4, which is kind of a neat shortcut. We're just going to leave full absolute cell reference because that's all we really need. All right, once we've done that, we've got $G, $1 minus C2. Go ahead and flash fill. And now we've got 200 items here that all have days past due. Okay, so There's a lot of ways we can go about this, but because this is a pretty straightforward analysis, let's just go ahead and create a pivot table. We're actually going to be doing pivot tables for both of our exercises. I call this Dr. Caden Appreciation Day, okay? But because of the way she feels about pivot tables. So let's go ahead and let's go through, we're going to do a couple different ways to do this pivot table. We already know the basic ways, but let's go ahead and do an interesting shortcut. So let's highlight the entire table. And I would like you to do this. This is just for expanding some shortcuts. Click on cell A1. And what I'd like you to do is I'd like you to learn the shortcut for picking up an entire data set. So hold down your control key and your shift key, then press your right arrow. It's going to pick up A1 through D1. And then I want you to do the same thing. Keep your control shift key held down and press the down key. That's going to select the entire table. That can come in a pinch. Now, obviously, if you really wanted to, you could just go, all right, well, I just like highlighting Dr. Barnes, and that doesn't take all that time. And you're right. It's not actually that big a data set, so you could actually highlight that way. If you get thousands and thousands of rows, it might be more convenient to just do that. So by going to the control shift key, you can actually pick up full population, because control basically says, I'm going to lock in that cell, then move from cell to cell. When you have shift, it's going to say, I'm going to lock in that cell, and then go ahead and go to the far range of cells. So that's why control shift right and then down will pick up the entire table. So kind of a shortcut. All right. Once you've selected the entire table, go ahead and hit Control T. And it's going to actually give us the create table shortcut. We're going to say we've already got our table highlighted. All right. Table has headers. We're good. Click OK. And we're going to summarize this with a pivot table, as I said we were meant to. So we'll just say this is going to be table range table 1. We're going to put it in new worksheet. We don't need to actually make any modifications. All we have to do is once we've got that set up, click OK. All right. So the other side of the pivot table, let's go ahead and make sure that we set up the parameters the way that it specifies in the exercise. Okay. So I do this wrong all the time. So we're not going to have any columns. On the rows, we're going to put days past due. And then in values, we're going to put invoice amount. So rows are days past due. Invoice amount goes down to values. I'm just curious about something. Yeah, okay. I'm just going to do this. In the past, all I've done is I've changed, oops, I don't want to do that. I want to see if I can duplicate invoice amount. Yeah. So in the past, all I've done is just one invoice amount, but I think what would kind of be interesting is to have different calculations of invoice amount. So I'd like you to drag down invoice amount twice. And for the first one, we're going to change the parameter. We're going to change the value field setting to count. That way I have a count of invoice amount and then a sum of invoice amount. Instead of just having to default to one or the other, we'll just do both. Why not both? Why not both? All right, so now we have summarized data, but it's summarized according to the number of row labels. Remember what our goal was to actually have a full accounts receivable aging, which is going to be the days 0 through 30, 31 through 91, so on and so forth, or 1 through 30, 31 through 90, so on and so forth. So let's go ahead over in row labels. I'd like you to click on or right click on here and scroll down to where it says group. And it will auto default to whatever the minimum and maximum values are, but we're going to go ahead and enter our own values. We're going to start at 1. We're going to end at 180. And we're going to group by 30s. Start at 1, end at 180, group by 30s. All right. Once we do that, look at that. We've got a pivot table that's sorted or grouped according to the accounts receivable aging. Which that would have saved a lot of time back in 302, don't you think? Yeah, just to actually have this available to you and say, Dr. Eisen, your tasks that take me hours on end for homework, I could have done this in Excel. Curse you for not letting me know. If you want to write an angry email to Dr. Eisen right now, I fully endorse that. I fully endorse it. Now, one of our other tasks, if you remember, is that we wanted to actually have the records for 61 to 90. And the nice thing is, in the pivot table, you can actually draw data that's based from the pivot table. So if we click on 61 to 90, go ahead and double click on the 61 to 90 section. Oops. I'll show you the information there. You also click over on, this is what I was trying to say is, you also click on the count of the invoice amount. You can split it out into a full detail, all of it's on another sheet, which is kind of neat too. Right. So that's a pretty easy descriptive analysis in accounts receivable aging, something that you're probably somewhat familiar with already, but an easy way to go about that. If you got the data, put it into a spreadsheet. All right. Let's go ahead and do our second analysis. So now we're going to talk about segregation of duties. So segregation of duties, we've talked about that in this class. Does anyone remember the 3 letters for segregation of duties? CAR, custody, authorization, recording of transactions. In order for proper segregation of duties to exist in an organization, people in a certain process area must have separate responsibilities for custody of transactions, authorization of transactions, or recording of transactions. Those do need to be separated out. So it tells you a little bit about the inside. It says the people who handle cash can't keep the records or write the journal entries. Those who authorize payments can't handle cash, so on and so forth. We're going to be actually performing a test of separation of duties, or segregation of duties, I like to call it, by comparing who entered a journal entry and approved a journal entry to see if all transactions maintain adequate segregation of duties. So this is a test of controls, which I'm very fond of because that's what I like to do as an auditor. So what are we going to do? We're going to look at information about authorization and entry of transactions to see if there's any overlap. So this is going to be dataset 2, part 2. This is a list of journal entries. Now, you're probably going to be saying, this seems like a very, very sanitized list, Dr. Barnes, and you're absolutely right. This is nowhere near what you would see in a real world for journal entries. First of all, I think there's exactly 50 journal entries, or yeah, so I guess it's 52 journal entries. Every single journal entry has exactly 2 lines, 1 debit and 1 credit, which in the real world, that doesn't work that way. You don't actually have that clean series of journal entries. But that being said, for simplistic purposes, this will do what we want for it to do. All right. So what are we going to do here? Well, we're going to do a pretty basic analysis. We're again going to do a pivot table, but we want to actually understand what's going on here. Now, I want to make sure we understand this is a diagnostic analysis. What we're going to have when we're done here is a starting point for our diagnostic analysis. It's going to enable us to answer the question, but we'll talk about what our next steps would be after we finish this, because the actual pivot table itself will not answer our question. So let's just go ahead and do our traditional pivot table and just go and click on Insert Pivot Table. And we don't need to default anything. It should pick up sheet 1 and all the data in sheet 1. And we can just put it to a new worksheet. All right. So I'm going to go back to here and look at the data. When we create the pivot table, it actually has some very specific items in step 2. It says columns and approved, rows and entered, and sum of values and debit, which I tended to mess up. One time I did this. I put columns in I put the approved in the rows and enters in the columns, and my students were thoroughly confused, and I was thoroughly confused, and it was not a good look for me. So I'm just going to go ahead and make sure that I've got that set up. So the columns are going to be approved. Rows are going to be entered. And then the values are going to be debit. Now, it really doesn't matter if we use debit or credit here, because the debit and credit are going to sum up to the same amount, since every single debit has an offsetting credit for the same amount. We just need an amount field, and that was the one they default to. Let's go ahead, just for simplicity purposes, let's go ahead and change a value for debit to count, because we're more interested in the number of transactions than the value of those transactions. All right, I'm going to make this table a little bit easier to read. We can make some adjustments here. Column labels, we can change that to actual approved. Actually, it may even drop down just to approved. Oh, no, okay. All right, the drop down is a filter. And then we're going to set this up as entered. All right. So what do y'all think? Is there any issue here? Does anybody observe an issue in this particular series of transactions? So again, our goal here is to observe segregation of duties. And the goal would be is that the people who enter transactions should not be the same people who approve transactions. Do we have any problems that you can observe just on the simple data set? It appears that we have one user that appears in both entry of transactions and an approval of transactions, which that's bad enough if you have the ability to both enter and approve transactions. But here's another quirk, is that this individual only had one approved transaction and they approved their own transaction, okay? So for context, this basically is saying that they had entered a transaction which may or may not be legitimate. And so some authorization step said this is a legitimate transaction. They bypassed that by saying, yep, it's good. Go ahead and move it forward. All right. So could this be fraud? Possibly. It could be completely, totally honest. They just wanted to move something forward, but it's not something that should occur in an organization. So by identifying this, we would say this is a problem. Now, what I said earlier is this being a diagnostic analysis. This is not sufficient to complete our diagnostic analysis. Why? Because the question that we ask in a diagnostic analysis is, why did something happen? We know what happened. This user, assuming that the VR initials are the same user, it's possible that you could have VR being two completely different individuals just with the same initials. Is that possible? Yes. In this scenario, probably not likely, as there's a limited number of individuals. So assuming that VR is the same person, we want to know the answer to the question, why did the same individual enter and approve their same transaction? And there's a few questions that we want to answer about this. The first question is, why was the system set up in such a way that this could even be possible? And secondly, if this was possible, why did this transaction take place in this manner? Was somebody absent, is sick, was not able to authorize the transaction, and somebody had to push something forward quickly? What is the reasoning behind this? These are questions that we'd want to investigate looking into this particular transaction. So again, very, very simple, but a very, very interesting conclusion. So because we see something that should not happen. We should not have an entry of transactions and approval transactions by the same individual. We shouldn't even see the same initials across entry and approval, even if they're not the same person or for the same transaction. So again, very, very simple analysis. We'll move on to a little bit more robust analysis next week, but we're starting off pretty simple for today. And hopefully that wasn't too hard to pick up. All right, let's go ahead and move on to our AI activity. So we're going to be talking a little bit about chain of thought prompting. And one of the things about this, it comes with some things we've talked about already, okay? So we've seen AI tools, especially large language models, are very eager to please. Has anybody when they've been working on these tools, just become like, you know, this LLM is really polite. It seems like it really is just this is somebody I'd want to be friends with. The piece of code, okay? So don't complete your feelings there. But yeah, they generally are very eager to please. They just want to do something. And to the extent that they're eager to please, they will make up stuff if you keep going, okay? So if you ask it a question that doesn't know the answer to, it very rarely said, I don't know the answer. It will say, let me give you the best possible interpretation I have for that answer, and that answer could be completely wrong. Now, admittedly, these AI tools are getting much better over time as they have more and more information and more input. They tend to get better. So a very interesting insight on this. I think I told you that we were using a large language model tool analysis for my seminar and auditing class, my graduate auditing class. We've done this for the past 2 years. And last year I had my students enter into ChatGPT 3.5 several CPA exam questions, see how they did. And the pass rate was pretty abysmal. It was like 40%, okay? Had them go forward 1 year, this past semester, this is about a month or a month and a half ago. Does anybody think that the pass rate improved on ChatGPT 4.0? Yeah, it was nearly perfect. It was nearly perfect. There was like 2 questions that it consistently missed across the analysis. So that's a massive improvement over a 1 year span of time. So we do know that these tools are going to be more effective over time. They will give you much more accurate answers. The interesting point is that a lot of people will assume that these answers are correct without understanding context, okay? That was the value proposition that I said what you're going to have is that if you're an expert in a particular area, you are going to be the ones that are going to be training the AI and making sure they have the correct outputs. But you need to know what the correct outputs are. What about if we could actually improve that process? Make it so that we can actually understand the judgment and the criteria that the AI tool is using. Make sure we follow the steps in the process so we can see what is it doing, how is it coming up with the conclusion, and is that process appropriate? That is the goal of today's activity, is to make this process easier on us to make sure that the output is correct, okay? We want to try to make sure they're contextually correct, so that's what we're going to be going here. So is everybody familiar with Bloom's taxonomy? Ever heard that term before in education? So education is basically supposed to be a pyramid structure of how your analysis of thought is supposed to be working. And starting out at very basic education, this is kind of what you start out at grade school. And I will say that we still use this at the college level, though usually it's conditional. It's conditional. Like very few of the questions I ask in this class are going to be pure memorization questions. They do exist, but very few of them do. Instead, we all want to make sure that we can actually take this information, we can apply it in certain situations, we can analyze the information and its value, we can use it to evaluate and create whole new topics and whole new exploration here. Funny story, by the way. For those of you who are interested in taking the CPA exam, there's actually 4 levels of Bloom's taxonomy present in CPA exam questions. The basic ones are starting out remembering and understanding, those are just memorization questions. Then there's application, which is applying the facts, facts, rules, concepts, and ideas. Analysis, and then the highest level of reaches evaluation. And I made the joke that we don't actually get to the creation level in accounting because a creative accountant is committing fraud. And so that's kind of why it limits on the CPA exam. We get to the highest level of creative evaluation. We're not allowed to create stuff because that's just not good. But again, it is a sequential step. And as this diagram says, if we want to get to these higher levels, then we can't skip these steps. So we need to understand what is the foundation before we can get to this point here. Now, I know it's very, very easy when we're using AI tools and LLM tools to say, I trust the output. I'm just going to go ahead and use that output and assume it's correct. That's not going to be a rational approach. We need to make sure that the AI output that we're receiving is valid and accurate. So we need to go through some steps to make sure that's accurate. Fortunately, we do have some approaches that we can use today that are going to help out with that. So here's some types of prompt engineering. If you remember this, our first AI tool, I know that was like, this is like over a month ago when we started talking about AI tools and usage. We talked about prompt engineering. And we talked about it at a very general level. And the more specific information you get, the better. Well, one thing that a lot of new users to AI tools tend to do is they tend to operate at zero-shot prompt. They ask their question and expect the output. And if you think about it, AI tool is not that much different from logical perspective than we are. If we assume that somebody knows something, then they may be able to be effective in the response. But if they're not articulate in that area, it's going to require some research. And if they don't really know what direction they should be going, they may give you bad input based on their research, or bad responses based on their research. So zero shot is just asking the question and just basically hoping that the AI tool is going to be effective enough in that response. Prompt engineers in AI have actually figured out that you can be more effective if you provide better inputs to prepare the AI for the results that you want to generate. So they moved on to something called a few-shot prompt, okay? And a few-shot prompt is saying, let's go ahead and give it examples of these questions with the correct answer, so it can start to see the patterns in these questions. So instead of just saying, what is the break-even point when sales price and unit variable is 25 and unit price variable cost is $12 and fixed costs are 73,000. Instead, it says, here is the answer, and does that multiple times for several scenarios. So the tool itself should be able to see the pattern and be able to answer and respond. Here's the detail. Here's the answer. We can give you proper responses now because we've been properly trained on this. Okay, been properly primed. So that's going to be few-shot prompting, which is very effective, but it's really only going to be good if we're talking about quantitative analysis. What if we're talking about qualitative analysis? Or what if we're talking about deep thoughts into understanding why something is specific? That is where we get into the concept of chain of thought prompting, okay? Chain of thought prompting is basically trying to have the AI tool provide an explanation for its results and to be able to verify the information. So we actually go ahead and tell the AI tool what the break-even point is, and then tell it to do a step-by-step analysis so we can evaluate every single point in the analysis. Then we can look and see, this point was correct, this point was correct, this point correct, the answer is correct. Or this point was correct, this point was incorrect, this is what led to an incorrect answer. We can see the weaknesses in the response. So chain of thought prompt is pretty effective in analysis because not only do we get to make sure that the AI tool improves its analysis, but we get to actually help the AI tool improve and for future attempts. Now, there's also the idea of being role-based responses, okay? And I do think this has some value, particularly if we're talking about really high-level analysis. This is something that I use very frequently when I'm talking about how to use a new tool in AI, like how to develop a new tool. So one of the things that I was doing very recently is I was trying to develop an activity, an escape room-like activity. And I said, I'm an associate professor in accounting at a small Midwest liberal arts university. My students are very, very bright and I need something challenging for them. I wanted to create a escape room activity. I basically role play set the AI tool, said, you are me. How would you approach this? And it gave me a much different pattern of responses than it would if I just kind of said, create an escape room activity for a bunch of college students. That's a lot of different techniques that would be in play there. And so the role-based activity actually incorporates some of the tools that we use in the other prompt areas. So for prompt engineering, we're going to kind of approach this. We want to see if we can actually come up with something that's a little bit more legitimate approach. Now, again, for the chain of thought prompt, this is something that I think you should employ in your own analysis and questions that you ask. And the questions you ask do not need to be complex, but they do need to be critical. Okay, it's not going to be something like, I'm looking for a correct answer to a specific problem, like what's 2 + 2? Instead, you need to be asking more research questions about more quantitative subjective material. And the reason this is important is that what we're starting to see is these large language models, these AI tools, can provide better feedback if given correct prompts. So there's a recent paper, as you can see, it was just a little less than a year old, and it's a working paper. It talks about human analysts in the stock market. As long as there was chain of thought prompts that was given in the analysis, the AI tools were able to make better investment decisions than their human counterparts, which is kind of cool if you think about it. If we actually get to the point that this is effective, then that means a whole different generation of the approaches to the way people invest and the way they're going to react. Of course, part of the whole stock market approach and all of the capital markets approach is that humans behave irrationally. And so that may actually take irrationality out of it, which may take the fun out of it. So who knows? All right. So we're going to start out with kind of the same model that we talked about before, the ANSWER model, which you may have seen in other contexts called the SOAR model. But again, ask the question, master data, perform the analysis, share the story. We're going to start out kind of a basic statement on this. We're going to ask several questions to try to prime the model. So if you're not already logged into Copilot or ChatGPT, I think you should do that. Let's go ahead and let's do a very basic exercise. We're going to do a very basic activity. How many of you all are familiar with amortization concepts? They say that you've probably done that in other classes. So let's talk very, very briefly about what an amortization entails. So if you're buying a new asset and you're going to be financing it, there's an expectation that you're not paying for it all at once, that you're going to pay for it partially over time. Like a new car is a really good example of this. I recently just bought a new car and I financed it over 3 years, which is a little bit more than I really want to pay per month, but also means that I get done with the financing quicker. Anyway, I was trying to determine what my payment was going to be, so I was able to create an amortization table in Excel. And keep in mind, an amortization table is going to include the consideration of whatever it is you're paying per month, how much of that amount that you're paying per month goes towards interest payments, and how much of that reduces the principal. And that principal reduction will actually reduce the balance on your account over time. Now, the longer period of time that you perform an amortization, the less that goes to that principal and the more that goes to paying to interest, which is a big issue why people have problems with student loans. Hopefully, nobody has too many issues with student loans in this room, but I've heard horror stories about students who have left school and they've had $100,000 in student loan debt and they expect to pay it off in their lifetime. And they look at the 30-year amortization of $100,000, and that's as much as paying for a house. You're paying like $800 a month on your student loans just to cover that, which is an absurd amount, particularly if we're getting to today's day and age, the student loan rates are really, really high. So having knowledge about how to do this is really, really important. And if you've taken some classes in finance or accounting, you probably have some familiarity with this. The question is, can we actually create a tool that will do this for us? And the good news is, yes, we can, okay? Now, I'm not going to say, first of all, I'm not going to advocate saying, if this tool, this AI tool can actually do this for us, that we should do it. There are some issues, okay? There are some problems, some stumbles, but we're going to take a look at what it can and cannot do here in just a second. So here are the prompts that you want you to do. And by the way, these are prompts that I copied from another assignment. This last prompt is probably not necessary, but I do think that these other prompts are important. So what I'd like for you to do is I'd like you to go to Copilot or ChatGPT, whichever you prefer, and I'd like you to do these first 4 prompts to create a mortgage amortization schedule and some analysis. And this is going to kind of illustrate some of the patterns that we're talking about just for what an amortization looks like. So I'm going to give you a few minutes to do that, and we're going to talk about the results. All right, so how do you guys feel about the outputs? Pretty solid? So there's some interesting things to take away from here. So one of the points that I want to make about this is that We need to be able to analyze this information from our own perspective and determine what it is that we expect to see from this analysis. Now, if you come into this cold and saying, I don't know what amortization schedule is, and I don't know anything about loans or mortgages or anything like that, if you're completely cold to this, then it's not going to make any sense. But my assumption is everybody in this room has at least a passing familiarity of these concepts, having taken a finance and accounting course at least. So let's go ahead and answer these questions on our own real quick and see what we would expect to see. Now, we're not going to fully answer the questions. I'm not going to have you create amortization schedules by hand. That would take a little too long. But I do want you to know what the expectations are that you would be able to see. So first thing is I would like you to create a mortgage amortization schedule. What input do you need? So based on the prompt, the second prompt, that should be able to respond pretty effectively that we need the loan amount, the mortgage amount itself, we need the annual interest rates, the loan term, and the start date. Those seem to be pretty reasonable inputs. So when you put this into your LLM tool, that's basically what it came back with. It says it needs those inputs. Should have been close to something close to that. So I'm going to go ahead and I'm going to copy this over so we can actually take a look together as class. Got my own AI tool here. Oops, nope, that's not it. There we go. All right. And so it gives us pretty much information. So it does tell you that it refers to payment frequency. But for the mortgage, generally, mortgages are going to be on a monthly rate. So that's pretty straightforward. So we don't need to specify that as long as we say the monthly rate is. So let's go ahead and have it create a mortgage amortization table for us. All right. So a few things to note here. What is it that we want in our mortgage amortization table? We obviously want 360 observations. It's going to be 360 rows in the amortization. What information do you want to be contained in the attributes of this? Do you want the date? What else? We want to actually have the principal repayment, the interest repayment, and the running balance. Anything else that might be missing? We take a look at this. Let's go ahead and take a look and see what it came up with. You probably got something very similar to this. Sure, why not? So this one's actually pretty interesting. I will tell you right now, I ran this upstairs when I was checking this. This is not the same detail I got, which is very interesting that it actually came up with two different robust answers. But it actually says, here's the payment date, here's the payment number. It talks about the beginning balance, ending balance, payment, principal paid, and interest paid. And I was going to say what my expectation was is this, because this is actually what it responded or it gave me when I did this upstairs before I came up here or came down here. This actually added 3 whole columns to this. And I think this is actually a lot of value because this is what I want to see in an amortization table. I want to know, all right, what are my starting balance? What is the amount of payment that I have to actually make every single month during these amortizations? How much of that is going to go towards the principal, which means that that's going to be the reducing of the balance, and how much of this is going to go towards interest? And you can kind of see it gives us all of those details. It's formatted a little bit weird. It's not really cleaned up, but we can do the cleanup ourselves. But knowing what you know from amortization, if you saw this table, what you know from amortization, if you saw this table, what would your response be? Would you say this looks good or this looks problematic? I'd be pretty happy with something like this. If I came back and it came out with something like if it came something like that, I'd have a problem because I'd say, well, it doesn't have payment, and it doesn't really have comparison of the ending balance to beginning balance. I'd want to have more detail. But having this information right here, pretty potent. So this kind of reinforces the idea that when we're trying to actually train the AI tools, or we're trying to actually make sure that it's giving correct information, we need to have an idea of what the information should look like. Could I tell you what the beginning balance is after period number 13? Not off the top of my head. I don't have that kind of information, but could I tell you what the input should look like or what the eventual result should look like in an amortization table based on my experience? The answer is yes. This is what I would expect to see, a monthly analysis with the payment numbers and the balances and the payments going into with a delineation of how much is going to principal and interest. All right, moving on. So it's going to ask us what would the total interest paid to the payments were over 360 months, 180 months, and 120 months. So I'm going to go ahead and paste this in, but before I press enter, is this something we should already know have information about? Should we have a general idea of what we're looking for here? Yeah. So if we're paying over 360 months versus paying over 120 months, which is going to have a higher amount of total interest? Yeah, 360 by a large amount, by a long margin, okay? So that's what we should be looking for trend. We don't know what the exact numbers are, but that's what we're going to be looking for this representation. And if that representation is made correct, then yep, this sure looks consistent with what I expect. And we can actually even validate the 360 months because we can go back to our amortization table. We can just highlight this column and say this is $231,676. Is that consistent with what the tool told me? Yep, sure looks like it. So we can actually validate information based on other information that's given. It's consistently providing information. Now, is that an external source? It could have been wrong 2 times in a row. That's certainly a possibility. But this sure looks like what my expectations is consistent with. So I'm happy with that. All right, final question. Provided graphical representation. The only reason I don't say that we're going to do the last prompt is the last prompt we've already done part of it. It's actually provided our Excel output for us because we did it in Copilot. We could also put this in a Word document, show the outputs here. That's kind of redundant though. That's the only reason I don't have that here. Oops, that's not what I wanted to do. Let's try that again. So graphical comparison. Graphical comparison should just be consistent with the result that we just saw before. And I'm curious because I was not terribly impressed with my graphical output when I did this upstairs on my computer. Hopefully this is something a little bit more interesting and engaging. Oh, this is completely different from what I looked at before. This is still not a great graph, okay? But the one that I had before actually had 3 thin lines, and one was like 2 of them over here, the 180 months, and 360 months was way over here, and just like really, really thin colored lines. This one I think I could actually put into a document and pretty be reasonable that it would be something I could use in a report. But yeah, different outputs, different formats, and consistent with my expectations, and certainly consistent with the previous results. So again, checking this information to make sure it's consistent with our expectations and making sure that we're actually coming up with consistent results. That's kind of the goal of this chain of thought prompting. And this is just an example of this. We'll probably look at another example next week to kind of reinforce these ideas. But for right now, this should kind of give you a clue as to what you should be doing as developing your research with the topics that you're going to be having in this area. So, all right, we are done for today. We're done for this week. I will see you next week for chapter 11.